So when you're looking at systems of equations and you want to solve them, you can graph them if you like graphing. But graphing only works if you don't need an exact answer, because sometimes they don't line up properly, and so you might be estimating. Substitution works best if you have an x or a y that are alone with no coefficient. So you can have x equals or y equals. And that allows you to substitute in for the other and solve. Elimination with addition or subtraction works when one of the variable expressions will cancel each other out. So the x's or y's have the same coefficient. So you can just add or subtract the two equations together and they cancel out, like we did on Thursday. Elimination with multiplication, you use that when substitution or regular elimination won't work. None of your coefficients match, and so you have to force them to match. So you have to multiply either one or both equations by some number to get coefficients that match so that you can cancel things out. Now, the next thing we're going to learn is called Cramer's rule. And when you do learn that, you can use it anytime. It always works. Okay. Now the only thing is, the equations have to be in standard form. So if they're not, you'd have to put them into standard form to make it work. And that's when you have your x plus your y equals your number. So they have to be in order that way. After that, though, it always works. And the first thing we want to do is decide which method do we want to use. Okay, I have no matching coefficients. So I either have to use multiplication to make things match, or I have this y by itself, so I could rearrange this and use substitution. Which one do you think would be the easiest? Substitution. Okay, so we'll use substitution. It's a personal choice. Yeah, like I could either multiply this all by 4, or I could use... Personally, I'd multiply this one by 2, probably, and do elimination with multiplication. But a reason? No. Just because that was a positive 4 and this is a negative 8, and I go, oh, that's just a 2, and then 2's are easy. But substitution works equally well. I'm going to turn this into y equals 8x plus 19. I picked up that 8x and I put it to the other side, so now it's positive. I'm going to take this 8x plus 19 and I'm going to substitute it in for that y right there. So I'll get 4x minus 4 times 8x plus 19 equals 8. So 4x minus 32x minus 76 equals 8. So negative 28x minus 76 equals 8 plus 76. And I get negative 28x is equal to 84. Did I do that right? I'm just going to double check myself. Okay. I'm going to divide both sides by 28. Well, negative 28. And x equals negative 3. And then to find out what y equals, I plug the negative 3 in here. So I get negative 24 plus 19, so that is negative 5. So my answer is negative 3, negative 5. Okay. How about this one? Which one would we use? My x's don't match, but my y's match, right? So I'm just going to use elimination. So I'm going to just kind of fix this because it, for some reason, isn't lining up properly. So you could rewrite it to line it up properly. I am going to subtract this whole thing. So what that's going to do is it's going to change all of the signs. So that negative 2x becomes a positive 2x, the 7y is a negative 7y, and negative 9, because subtracting changes signs. So I'm going to get 7x is equal to negative 7, which makes x equal to anybody. Thank you. Negative 1. Now I can take that x and I can plug it into either the top or the bottom equation. Bottom? Got it. So I have negative 2 times negative 1 plus 7y equals 9. That gives me positive 2 plus 7y equals 9. Subtract 2, 7y equals 7, so y equals 1, so you have your solution. Okay. All right, a matrix is an array of numbers. What columns has an n in it? Okay, and a matrix is just an array of numbers. These are matrices, or this is a matrix. Together they are matrices. That's the plural. Okay, the elements. The elements. No, you can't solve. You can't solve this. There's no solving. It's an array of numbers. It's a way to organize numbers. Now we can use matrices to solve things, but you can't solve a matrix. Does that make sense? Because a matrix is just a way to organize numbers. It's a tool. Yeah. So elements are the number or letter inside the matrix. And they're named by the row and then the column.
What do you use the tool for? How do you use it?
Okay, matrices are frequently used in algebra and linear algebra. What we're going to be doing is using the matrix to solve a system of equations. But in order to do that, first I need to teach you about the matrix, and then I can teach you how to solve. See how this is A11, A12, A13? This is actually not A11, this is A11, A12. The first number is the row. The second number is the column. Okay, rows go across, columns go up and down. Yeah, so this is the first column, first row, first column. That's the element in the first row, first column. This is the element in the second row, third column. 2, 3, second row, third column. Make sense? Okay, so A4, 6 would be in the fourth row, sixth column. Okay. So each of these A's is an element, or each of these letters is an element. An element just means any number or letter that's inside the matrix. Okay. The dimensions of a matrix is the row and then the column. And now you don't multiply these. It's just like you talk about a piece of wood, 4 by 6. It's kind of like that. You can have a 4 by 6 matrix with 4 rows, 6 columns. So this would be a 3 by 3 matrix. And so with this, because they have 3 rows and 3 columns. Now this one has like a parenthesis, and this one has a bracket, and either of those are okay. No. The only thing you don't, if you have straight lines, like kind of similar to absolute value, that means something. But you can have a parenthesis or a bracket, and it's the same thing. It just indicates that you have a matrix. The dimension is row by column. So I have a 3 row, 2 columns. This is a 3 by 2. And this element is in the first row, second column. So this would be A12. First row, second column. We have 1 row, 4 columns. So this is a 1 by 4. This would now be B because this is a B. And it would be the first row because there's only 1 row, 3rd column. So rows go straight across, columns are up and down. How about this one? Rows first. 2 columns. Okay. This would be C, second column, second row, or second row, second column, 22. So C22. And this would be a 2 by 2. And this would be D, second row, second column, 22. We can look at this because we're in this kind of organized, we don't have all this other, what school had the most first place finishes? First place are 10, each school is a row. First row has the most 10s. It's easy to look at this way. If you had more and more schools, it would be easier to look across and see all that data faster. So it would be North. North had the most first place finishes. Okay, if we look at this, we could arrange it a couple ways. We could put the matinee and evening as the columns, and the adult and the child as the rows, or we could put the adult and the child as the columns and the matinee and evening as the rows. So do we want matinee and evening to be rows or columns? Okay, so this will be row 1 and row 2. And then adults will be column 1. Whoops, 1 and column 2. So matinee for an adult, for a child, evening for an adult, and for a child. Easy enough? The first step to adding matrices is they have to have identical dimensions. So 2 by 3 can be added to a 2 by 3, but a 2 by 3 cannot be added to a 3 by 3. They have to be the exact same size. So that's not a Z, that's a Z. Okay. And then the second step is you add corresponding elements. Okay. So if we look at A plus B, 2 by 2, 2 by 2, I can add those together. So what I'm doing is I'm adding corresponding elements. So 12 and -4 are in the same position, so I add those together. 2 and 4 are in the same position, so I add those together. -9 and -3. And 15 and -10. So my answer will be 8, 6, -12, 5. Does that make sense at all? I add those two together. And then these two together. It's not distributive, it's adding, but I'm adding elements that are in the same position. So the top corner gets added to the top corner. Does that make sense? Okay. Now B plus C, B is a 2 by 2. C is a 2 by 1. I cannot add those together. They have to be the exact same size. 12 plus negative 2 is 10. 8 plus 4 is 12. Negative 3 plus 1 is negative 2. Negative 7 plus negative 1 is negative 8. Negative 6 and negative 9 gives me negative 15, and 9 and 5 gives me 14. Not too bad. It's much like adding matrices. First, the matrices must be the same size. So if you have two different size matrices, you can't subtract, just like you can't add. And then step 2 is you subtract corresponding elements. So the same as adding, except you're subtracting. Okay, so if I said to do B minus A, B is a 1 by 3 and A is a 2 by 3, can I subtract those? Yeah. I can't do that. Okay, if I wanted to do A minus C, they're the same size, so I can do that. But what I need to remember is I'm subtracting, so that changes every single sign. So this is the same thing as adding the opposites, right? So if you're doing minus negative 10, it becomes plus 10. So don't forget that. So 4 minus 1 is 3, negative 2 minus negative 3, so plus 3 is 1. 8 minus 5 is 3. Negative 17 minus negative 10, so plus 10 gives me negative 7. 10 minus 8 is 2, and 6 minus 7 is negative 1. If we subtract these, I have 2 minus 6, negative 5 minus negative 3, 8 minus negative 9, and 12 minus 1. So that gives me negative 4. Minus a negative is a positive, so that's negative 5 plus 3, so that's negative 2. Minus a negative again is a positive, so that's 8 plus 9, so that's 17 and 11. You've heard about like models being made to scale, or maps are drawn to scale.
Oh, yeah.
The scalar is the multiple difference between like the scale model and the actual thing. So if you make something 1/10 the size, the scalar is 10, because you've multiplied the little thing by 10 to make it the big thing. So this is the proportion.
So it's like the increment of the scale.
Yeah, between two things. And it's yeah, it's the increment.
Or the ratio thing.
Yeah, or the ratio. Okay, scalar multiplication is when you take a matrix and you multiply it by a scalar. Okay, so step 1 is really your own, multiply everything. Scalar multiplication is pretty straightforward. I take everything in A. If If I want to find 4a, I'm going to multiply by 4. So it's going to be 4 times 2 and 4 times -4 and 4 times -7 and 4 times 9, 4 times 1, 4 times -10, 4 times 8, and 4 times 6. So 4a is going to be 8, -16, -28, 36, 4, -40, 32, and 24. Here I've got -3a, so I'm going to multiply everything by -3. So I have 27, -9, -15, +33, +6, -21. 2b, so -24, +16, -6, 0. If you're talking about a determinant is something that you can evaluate from a matrix, and it involves the sum of the products of one diagonal minus the sum of the products of other diagonals. But in a 2 by 2 matrix, it's really simple. You make an X. AD minus CB. This is the determinant. Now, to write a determinant, you can either put a DET in front of your matrix, or you can use the straight lines, like an absolute value. Both of these mean determinant, to find the determinant of the matrix. So with a 2 by 2 matrix, it's downward X minus upward X. So I would do 3 times 7 minus 2 times -5. So that would be 21, -2 times -5, so plus 10. So the determinant of this matrix is 31. I'm not going to get into a lot of what determinants are used for. There's a whole bunch of stuff kind of in more advanced math, but at this point we just need to be able to find the determinants because we're going to use those to solve the system of equations. So any questions on the cross multiplication to find these? So this times this minus that times that. Okay, so Cramer's rule. There was a mathematician, his name was Cramer, and he developed this ability to use matrices to solve systems of equations. And what he does is he finds, you use the coefficient matrix. Coefficients are what comes on the x and the y. So you have to have these lined up with x plus y equals number, x plus y equals number. The coefficient matrix is A, F, B, G. Okay? And then the determinant would then be A times G minus F times B. In order to solve the system, you take M and N, that's the two numbers here. So if you're solving for x, you replace the x coefficients with basically the answers over here, and leave the y's and divide by c. If you're finding the y's, you keep the x's, replace the y's, and divide by c. So the first thing you want to always find is c, because you have to use it twice. Okay, so that's 5 over 3, -6 over 4. So that's 5 times 4 minus 3 times -6. So that's 20 plus 18, so that is 38. Okay. I took, for C, to find C, you do the x's and the y's. And then you find the determinant. So you do 5 times 4 times and 3 times -6, and you subtract them. So that gave me 38. So that is now the denominator when I try to solve for x and y. Okay. To find x, I'm going to take the determinant this is M and this is N. So here I'll do, this is A, this is B, and this is M. This is F, this is G, and that's N. Okay, so to find X, I put the M and the N, and I keep the Y's. Well, I found C already, that's 38. So I cross multiply these. So I have 15 times -4 minus -29 times 6. Divide that by 38. Okay, so 15 times 4 is 60, I think. Nope, I actually have to hit the times. So I have 60 plus 174 divided by 38. $6.15. And then Y, I ran out of room. I keep the x's, so 5 and 3, and I replace the y's with 15 and -29. So I do, divide that by c. So it is 5 times -29 minus 3 times 15 divided by 38. So I have 100 divided by 38. So 2.63. So the solution to this system, if you were using like elimination with multiplication, you would get fractions or decimals. But using Cramer's rule, we just had whole numbers up until the very end, and we get 6.15, 2.63. Cramer's rule will always work. Okay, so C is the coefficient matrix. So that's the x's and the y's. So that's 7 times -7 minus -5 times 3. So it's -49 plus 15, which is -34. Okay, that's C. To find X, I take the X's out and put the answers here in and keep the Y's. And divide that by -34. So I get 37 times -7 minus -41 times 3 over -34. So -259 plus 123 divided by -34. To find y, we leave the x values in and replace the y values with the answers and divide by -34. So this would give me 7 times -41 minus -5 times 37. Oh, for 41 times 7? Yeah. So -287 plus 37 times 5. 185 divided by negative 34. Oh, so it's 3. So my solution would be 4, 3. Okay.